Hi students, welcome back to my channel Evolve Solving Physics. In previous class we discussed about the introduction of electric current, that is current electricity. We discussed what is meant by electric current, instantaneous current and types of electric current. So today we are going to discuss how current can be calculated in different situations. First, suppose if they have given charge q and time t, we can calculate the current as I equals to q by t. First, suppose if they have given different terms and they say to calculate the current. So, based on that concept, today we are going to discuss a current can be calculated very easily. By using simple formula, we can calculate the current in different situations. So, first one, due to translatory motion of a charges. So translatory motion of charges means the charges moves uniformly in the same direction. That represents translatory motion of charges. So first, suppose if they have given, if n particles are given. N particles, each particle, these n particles each have a charge q. So we are considering n particles, each of the particle having the charge q. So every particle having the charge q passes through a area A in time t. Then I is equal to. So we know that current I equals to q by t, charge by time. They said that n particles each having charge q moving in area of cross section A in time t. So how you can write the formula means n q by t. So the current formula is I equals to n q by t. Here n particles are considered, each particle having the charge q moving in area of cross section A in time t. So the current can be calculated as I equals to n q by t, because n number of particles each having charge q in time t. So I equals to n q by t. So next one is due to rotatory motion of charge. So we discussed here the charges move in translatory motion. Here the charges are moving, the charge is moving in rotatory motion. As you all know that rotatory motion means circular motion, as charge is moving in circular motion. Here the charge is moving in a rotatory motion and from center to charge q is considered as radius r, and this charge is moving with velocity v. So now we know that what is the formula for velocity? Velocity is equal to displacement by time. Displacement by time. So, and these containing the charge containing the displacement of s. So, v equals to s by time t. So, send t to left hand side, vt is equal to s, t equals to s by v. So, here the displacement is considered as, so what is meant by displacement means the length of the path traveled by an object in specific direction. The charge direction is in circular motion. Circular motion means the displacement is considered as circumference of the circle. As the charge is moving in rotatory motion means charge is moving in circular motion. As the charge is moving in circular direction means it represents its direction in a circular path and having the distance of s. Distance and direction represents displacement. So displacement is considered as circumference of the circle. What is the formula for circumference of the circle? 2 pi r. So this can be written as 2 pi r by v. T is equal to. So what is the formula for current? I is equal to q by t. So as you all know that relation between time t and frequency is F equals to 1 by T. F equals to 1 by T. The relationship between time and frequency is frequency will be equal to inverse of time period, or time period will be equals to inverse of frequency. So 1 by T can be written as QF. So you should remember I equals to Q by T, 1 by T is equal to F. So by substituting T value in I equals to Q by T, you will get the current formula when a charge is in rotatory motion. So you will get I equals to Q by T, T is 2 pi R by V, Q by 2 pi R by V, make the reciprocal of denominator, you get Q into V by 2 pi R. So I equals to QV by 2 pi R. So when you will use this formula means when they have given a charge is moving in rotatory motion of charge Q and angular velocity V. V is the angular velocity or velocity, and radius R. So then you can use the formula I equals to QV by 2 pi R. V equals to angular velocity and R is the radius. First, suppose if they have given diameter in place of radius, you know the relationship between diameter and radius, that is D equals to 2R. By using this, you can calculate the radius and they will give angular velocity and charge. Then you can calculate the current I equals to QV by 2 pi R. For suppose if they have given angular frequency. So angular frequency is denoted by omega and the units will be radians per second. So we have one formula for angular frequency, omega equals to V by R. So substitute this in equation 1. Substitute in 1. So what you will get here, I equals to omega in place of V by R. You will get Q by 2 pi into omega. So will you get as I equals to Q omega by 2 pi. So this is the formula you should be used when they have given angular frequency and charge Q. So I equals to Q omega by 2 pi. Omega is the angular frequency and the units will be radians per second. Just remember that if they have given frequency and charge, you will use the formula I equals to QF. If they have given angular velocity, radius and charge, you will use the formula I equals to QV by 2 pi R. If they have given charge Q and angular frequency, you will use the formula I equals to Q omega by 2 pi. You should remember these three formulae to calculate the current from these three of these situations. So next one is current density. So current density is denoted by J. J bar represents, as current density is a vector. The ratio of current to the area of cross section is defined as current density, that is J equals to I by A. And this current density can also be defined as amount of charges flowing per unit area of cross section per second. Current density J equals to dq by A dt. Why I am taking dq by dt? dq amount of charges flowing in area of cross section A in time dt. As time is changing, the amount of charges is changing, but there will be no change in the area of cross section. So dq by A dt. So as you all know that dq by dt is current I. So I by A. So the current density J equals to I by A. So from this you can calculate the current I. If they have given current density and area A, you can calculate the current I. J equals to I by A. As I said that current density is a vector quantity, so its direction will be along the positive charges. So the current density direction will be along the positive charge. So next, drift velocity. What is mean by drift velocity? Before knowing about drift velocity, you have to know about electric field. Just remember that electric current and electric field both are so different. Electric current means for a given area, if they have given electric current, number of charges will flow through the area in time t. That is I equals to Q by T. What is electric field means? If as we are giving electric field to any conductor means it containing an area A. As we are giving electric field means number of charges are produced from that conductor or metal through an area A. That charges will produce us some force by the charges by the attraction of charges or repulsion of charges. So that can be defined as electric field. So electric field E is equal to F by A. So it is also a vector quantity. So electric field is equal to force by area between the charges produced in the conductor. Current is charge by time. So number of charges produced in area A in time t. So I equals to Q by T and E is equal to F by A. So why I am saying electric field means this electric field is related to the drift velocity. What is mean by drift velocity? So average velocity obtained by free electrons inside a metal by the application of electric field is called drift velocity. By giving electric field to the metal, we need the average velocity of the free electrons. That average velocity is called drift velocity. So we get drift velocity based on electric field. So drift velocity is depends upon electric field and nature of the metal. It also depends upon nature of the metals. Drift velocity is denoted by V suffix D. So for metals, drift velocity is of order of 10 power minus 4 meter per second. So the average velocity for some of the metals will be that is average velocity means drift velocity for some of the metals will be 10 power minus 4 meter per second. As we discussed that drift velocity is obtained from electric field. Without any electric field, we cannot calculate the average velocity of an free electron in the metal. So by this we can calculate the mobility. The mobility is denoted by mu. The mobility of charge carriers like electrons is the ratio of drift velocity to the electric field. With these two relation, we get the mobility. So mu equals to Vd by E. This is the formula for mobility. Mobility is the ratio of drift velocity to the electric field. Without electric field, we can't calculate the drift velocity. By these two combination, we can calculate the mobility. So mu equals to Vd by E. How experimentally the mobility of charge carriers can be calculated means by using Hall effect. By using Hall effect, we can experimentally calculate the mu. So this is how current can be calculated in different situations. If you have any doubts in this topic, please comment me in comment box. So this is how current can be calculated in different situations, that is due to translatory motion, due to rotatory motion of the charge, and current density, drift velocity and mobility. This we will discuss in next class. The relationship between current and drift velocity and density and current density and drift velocity will be discussed in next class. So if you have any doubts in this topic, please comment me in comment box. Please like, share and subscribe my channel. Thank you.